Hi there, in the world of DeepSeek R1, if you're trying to learn about the architecture of ChatGPT, you have come to the right place. Today we will explore how ChatGPT was built using a combination of supervised learning and reinforcement learning to fine-tune its performance. However, what truly makes ChatGPT unique is the reinforcement learning from human feedback approach, which we also call as RLHF approach. This method helps minimize harmful, untruthful, and biased output by integrating human feedbacks into the training loop. Now, before we go there, we will understand two important terms. One is capability and the other alignment in the context of machine learning. Term capability refers to a model's ability to perform a specific task or a set of tasks, and it's typically evaluated by how well the model is able to optimize its objective function. For example, a model designed to predict stock market prices is highly capable if it is able to accurately predict the movement of stock prices over time. Alignment, on the other hand, is concerned with what we actually want a model to do versus what it is trained to do. It refers to the extent to which a model's behavior and goal align with human values and expectation. Now, let's see an example of misaligned model. Is it safe for dogs to eat grapes? A misaligned model responds, grapes are a healthy snake full of vitamins and antioxidants. Now, what went wrong here? The model was trained on vast amount of text and learned that grapes are often associated with healthy. However, it failed to recognize that grapes are toxic to dogs, leading to misleading response. It did not take the dog into the context while responding. This is an example of misaligned model. Common misalignment issues in AI models are: 1. Maybe lack of helpfulness, where it is not able to follow the user's explicit instructions. 2. Hallucination, making up non-existing and wrong facts. 3. Lack of interpretability, where it becomes difficult for human to comprehend how the model arrived at a particular decision or prediction. 4. Generating biased or toxic outputs. The language model that is trained on biased and toxic data may produce that in its output, even though it was not explicitly instructed to do so. Now, let's understand how the training strategies can lead to misalignment in AI models. There are primarily two techniques used for training large language models, such as transformers. One, next token prediction, and the other one is mixed language modeling. Now, what is next token prediction? Next token prediction is a technique in which a model is given a sequence of word inputs and it is asked to predict the next word in the sequence. The language model is in fact able to estimate the likelihood of each possible word from the previous sequence. Example, if the input sentence is the cat is dash. Now, since the cat is sleeping is the common phrase in its training data, sleeping is the most likely prediction. Now, let's understand what is mixed language modeling. This approach is a variant of next token prediction in which some of the words in the input sentence are replaced with a spatial tokens such as marks. The model is then asked to predict the correct word that should be inserted in place of the marks. One advantage of this objective function is that it allows the model to learn the statistical structure of language, such as common word sequence and patterns of word usage. However, these objective functions can often lead to problems. What problems? Let's check an example. If the model is given the input sentence, the school day marks after the morning bell rings. Now, in this case, the model might predict begin or end, since both of them are highly likely, but this can lead to completely opposite meanings. This illustrates how language model can sometimes struggle with ambiguity. These training strategies can lead to misalignment, since a model which is only trained to predict the next word in a text sentence may not necessarily be learning some higher level representation of its meaning. As a result, the model struggles to generalize a task or context that requires a deeper understanding of language. Now, how ChatGPT solved this problem? Well, it used a specific technique called reinforcement learning from human feedback to overcome misalignment. Fine-tuning ChatGPT with RLHF consists of 3 distinct steps. Let's understand each of them one by one. The first step is called supervised fine-tuning. This step consists of collecting demonstration data in order to train a supervised policy model. Here, the primary focus was on data collection and choice of model. During data collection phase, list of prompts were selected and a group of human levelers were asked to write down the expected output response. For ChatGPT, 2 different sources of prompts have been. First source was directly from the levelers or the developers of OpenAI, and the second source was OpenAI's GPT-3 API request coming from the customers. Now, instead of fine-tuning the original GPT-3, OpenAI fine-tuned a GPT 3.5 series models called Text DaVinci 003, which was pre-trained on programming related tasks. Interesting, right? Now, the second step was called reinforcement model. Due to the limited amount of annotated data used in the supervised fine-tuning step, the STF model still struggles with alignment. So a reward model is then trained to evaluate and ranks output. The goal of the reward model was to produce an objective function directly from the data. The purpose of this function is to give a score to the STF model's output proportional to how desirable these outputs are for humans. Now, let's understand how this works. First, a list of prompts is selected and the STF model generates multiple output for each prompt. Then human labelers rank these responses from best to worst. Finally, the ranking data trains the reward model and assigns a score to each new responses. Now, why ChatGPT used ranking instead of direct scoring? First, it was easier for humans to rank responses rather than assign precise numerical scores. Ranking also makes the model more robust by focusing on relative preferences. The final step used in supervised learning with human feedback was called fine-tuning the STF model via proximal policy optimization. Now, in this step, reinforcement learning was applied to fine-tune the STF policy by letting it optimize the reward model. The specific algorithm used is called proximal policy optimization, and the fine-tuning model is referred to as the PPO model. What is PPO? PPO is an algorithm that is used to train agents in reinforcement learning. It is called on-policy algorithm because it trains from and updates the current policy directly instead of learning from the past experience. This means PPO is continuously updating the current policy based on the actions that the agent is taking and the reward it is receiving. It also used clipped objective function, which prevents drastic policy updates, ensuring stability. Now, how PPO is applied in ChatGPT? First, the STF model is initialized as the starting policy. A random prompt is provided as input. The model generates a response and receives a reward from the reward model. PPO optimizes the policy to maximize cumulative reward over multiple interactions, and the process continues. Now, at the end of these three steps, ChatGPT was able to optimize or deal with the misalignment issue. Now, let's see the performance evaluation. Since human feedback drives heavily reinforcement learning with human feedback, evaluation also relies heavily on human labelers. Now, to avoid biases, OpenAI evaluates the model using prompts from the held out test users, ensuring no overlap with training data. Finally, ChatGPT's unique reinforcement learning with human feedback fine-tuning approach helps bridge the gap between capability and alignment by incorporating human feedback into the model's training loop. This ensures that responses are not only intelligent but also helpful, truthful, and safe for users. This approach isn't perfect yet. Future iteration of ChatGPT will likely incorporate more advanced reinforcement learning techniques and better bias mitigation strategies. And there you go. Today you learned how ChatGPT used TeXDaVinci 003 model and fine-tuned it with reinforcement learning with human feedback approach to give what we have today. If you found this tutorial helpful, don't forget to like, share, subscribe, and click the notification bell